The near-Earth objects, NEOs as they're called, turn out to be some of the easiest places in the solar system to reach in terms of the propulsion energy required. This video describes a hypothetical human mission to an asteroid that might pass nearby the Earth sometime in the 21st century. NASA asked DigitalSpace, a California company that has worked with NASA for many years, to create this design to show how NASA's next-generation Constellation program for returning humans to the Moon could also take on a so-called deep space mission like this. 2 Constellation launches are required. The first is an uncrewed Ares 5 launch of a booster segment called the Earth Departure Stage, or EDS, followed about 90 minutes later by an Ares 1 lift of an Orion crew exploration vehicle with astronauts aboard. Mounted atop the EDS is the NEO Surface Access Module, or NSAM. Astronauts in the Orion rendezvous and then dock with the EDS and NSAM, creating a complete stack, as it's called. When the appropriate launch window arrives, the powerful EDS engines fire, injecting the entire stack into a trajectory bound for the target asteroid. Approaching the NEO, the Orion and NSAM separate from the EDS and take up a station-keeping position nearby the NEO. The mated vehicles now match the NEO's rotation and begin a descent towards the asteroid's surface. Astronauts now rotate their joined vehicles to an NSAM down orientation so that they can scan the NEO for a promising place to moor their ship. Up until this point, the mission has been very similar to an Apollo approach to the Moon, but now some key differences emerge. Look carefully at the bottom of the NSAM, and you'll notice a ring of airbags. These have sensors on their surfaces and penetrometer probes between them. Mission planners are designing for what they call a soft contact and tether on the NEO's surface. Because NEOs are much less massive than the Moon, only a small amount of thrust will be required to balance the NEO's tiny gravitational attraction. So, mission designers don't refer to this as a landing on the NEO's surface, but rather a docking with it. It's more like one very small spacecraft meeting up with a very large one. When the stack first makes contact with the surface, software looks at the airbag sensors and penetrometer readings, decides quickly if it's solid enough to stay, or to back off and try a different docking site. If the vote is to remain, harpoon-tipped tethers fire into the nearby surface in a bid to keep the NSAM anchored and upright. The first small steps for humans onto a NEO had better be small indeed, as the ultra-low gravity will create conditions more akin to scuba diving than to moonwalking. Neonauts, venturing out on extravehicular activities as spacewalks are called, will probably need to keep a hand or foot on their vehicle at all times. Fortunately, the securely anchored tethers will perform double duty as handholds, allowing astronauts to make their way down to and around the surface. NEOs are likely to be very crumbly and dirty places. Any dust the astronauts stir up will likely float around them and cling to their suits due to static electricity. Working on an asteroid won't be like last century's lunar excursions. At first, Neonaut crews will only explore very close to their spacecraft. But they could climb back inside and hop the entire vehicle to other locations on the asteroid and take additional samples. Eventually, the Neonauts may use jetpacks, quite similar to the manned maneuvering unit used on the shuttle, to freely fly, perhaps quite far from the safety of the NSAM. A lot of asteroid might be covered in a single mission. But when it's time to go for good, the Orion and NSAM upper stage will unhook from the tethered decking segment and pull away for the return home. Firmly affixed to the NEO, the piece left behind will become a long-term robotic science station. Back in free space and Neonauts no longer, the crew will perform a direct entry flight profile back to Earth, dropping their NSAM living quarters and Orion service module along the way. Like other Orion missions, the crew will experience a fiery re-entry, a parachute descent, and then, most likely, a splashdown-style water landing and recovery. NEOs, it turns out, are individuals, each different from the other. Following this basic mission plan, additional sorties to other NEOs could be flown. Proponents of NEO missions cite several reasons for wanting to do these missions. They think that NEO samples, selected by an intelligent human science crew right there on the surface, will likely hold amazing planetary geoscience discoveries. The impact threat from NEOs is always present, so it's probably a good idea for our civilization to learn as much about them as we can. In fact, one asteroid, named Apophis, will make a close encounter with Earth in 2029. But perhaps most important, NEOs and icy objects such as active comets could be developed as rich resource stepping stones, supporting future human exploration and the eventual permanent human settlement of the solar system and maybe, one day, beyond.